I'm Mark Schettenhelm, product manager from BMC, and I really want to talk today about what I feel is the core issue with the mainframe, and that is this fear of change. And every site I go to, I hear the same thing. People are afraid to change anything. It's kind of the, if it ain't broke, don't fix it, but I think it goes further than that people just are afraid to touch the code and to work with it, and that is not a good environment for the modern mainframe to evolve. So in looking at that, we sometimes hear COBOL is the culprit. Oh, it's COBOL, and people don't know COBOL, and they can't do that. I think that COBOL's getting a bad rap. It's not COBOL. COBOL is a very simple language to learn and work with. And good developers just love picking up other languages. So it's not COBOL, I feel, but it's what we've done to it. It's the way the COBOL programs are, and it's also application knowledge. So when they say, oh, I don't want to work with COBOL, just insert, I don't want to work with that application. Is a better way. We shouldn't talk about COBOL that way. It's been a good language. It's still a good language. It's what we've done to them. So to survive and change, we need to change these programs, and yet there's a resistance to changing them. And I don't blame new developers coming in. If I don't have the tools to work with them, or if I work like it was in the 80s, that's hard. They shouldn't have to work that way. So what can we do to make it so they're comfortable with these applications, work with them, and expand them? And to me, that was what saves the mainframe. Because if you can't get people to change them, it doesn't change, it doesn't expand, we can't do all these wonderful things. It's, to me, the core issue. Make sense? So, come on, slider. So I mentioned that it's what we've done to them. It becomes really a nightmare to maintain these programs because they're so large. Typically in applications, they might have many different programs, but there's the monolith. And it could be 100,000 lines, 200,000. I've seen 500,000. There are some out there that are over 1 million. Historically, it was probably done because they didn't have source control. And so let's just put it all in one, and that's easier. We know now that is not the way to do it, that those programs were too large and it isn't efficient, or, oh, calling was a cost. That's what we're stuck with. And so we have these monolithic programs, and it makes it difficult to work with if one person wants to work with one, the other. So we need to realize that that's a core issue. And they have to have the tools to understand these programs and work with them. And even better, what if they could refactor those? When they say, I don't like COBOL, the other thing they're saying is, I don't like the architecture of what we've got with COBOL today. They're saying, I want Java. What they're really saying is, I want the architecture of Java, which we can do with COBOL. What we need to do is break apart these monoliths so they can work on them, and we can have concurrent development. Right now, if I want to work on one part of the program, I check it out and work with it. Someone else needs to work with it, they check it out, and then we get that conflict of working with it. Testing of it is a nightmare because you have to test the whole program. If we can break them apart into separate pieces, then we can work with that one piece. I can understand that one piece, not the whole program. I can have test data for it. It enables automated testing. It makes things go so much smoother. They have to take the hit to do it. And I've talked to a lot of sites that have done this manually. They build the business case to do it, but they get results. They get results from doing it because suddenly I can understand things, I can test them, I can work with them. And what we have is BMC AMI DevX Code Insights. It's our tool to go in and tackle this problem. That it can go in and understand the program, and it will go and have quick understanding of the unfamiliar code. We just toss code at them and expect them to work like it's the 1980s, and that's not going to happen. So with this is in Eclipse. We also have VS Code coming up. is you have the code in an editor. So you're working on the code that you've checked out and you're working with. We have the structure chart. So you can go in and see how that's all built. And when it calls another program, when it does a DB2 update, all that's there. The logic flow within each of those modules, and also the data flow. So you know where the data comes into the program, where it goes out. You can take any field and see where it came, where it goes, what statements that it's touched. All that understanding means anybody picking it up probably knows it better than the person who had worked with it for years. We also have code extract that will go in and break apart the program into separate subprograms, and a quick fix capability so that you can do things like there's dead code. There's a lot of dead code in programs, copybooks that aren't used. We identify all those things, right click, quick fix, comment them out. We talked about having them delete the lines and everybody was panicking. No, so we didn't make that an option. But we comment them out so that, it's the backpacker ethos that you should leave it better than when you came. And that's what we really want. If we can break these things apart, work with them, and leave them better, that makes it so that we can keep these COBOL applications going and keep the mainframe going. Another piece to this is Runtime Visualizer. And this gets to, you're placed with an application, you don't understand how it works, because while you may have the monolith, particularly with CICS, is you have many different programs. It could be hundreds. It could be a lot of programs calling each other. What this does is you execute it. Now, whether it's batch or online in CICS or IMS, and it tells you how it actually works. You don't have to instrument your code or do anything. You execute it, and while it's running, it will start to chart it instantly. And you can just watch it start going, and you'll know that it calls this, which does this database update, and you can see the flow of it as it works based on the data you give it. Great for analyzing, like, what happens when someone does an overdraw on an account, or what happens when we get a new customer. You can see that flow, you can save it and play it back and see that I call this table, I get that data, and then the next thing I do is call this program. And then that calls that, and actually walk through it, work with others, and understand these amazing applications in real time. And all they have to do is just execute it and have it, and they can save it. Something like that is a game changer to really get new developers to work with these applications. We have to give them those tools. And the other thing is Abend History. We talk a lot about understanding the applications, like I said, that we've got the structure chart and everything else, and they don't understand how a program is built. But I think what we're ignoring is that developers who had experience with an application also knew about the abends, the tricky parts of the program. What parts abend a lot? Where is that validation? What fails? When we onboard someone with a new application to them, they don't know the Abend history. They don't know the gotchas. To me, if I'm a developer, and what we have is the ability to, while you're working with the program, right-click and get that Abend history so that you can see it. And that way you would know, does this abend a couple times a year, or does it abend every 10 minutes? Makes a huge difference to me. And especially if it's in the paragraph where I'm working, my testing's going to be different. I want to make sure I don't reverse something that was put in there. Application abends, the abend history is so critical, and yet I think we're overlooking that when we're training new developers. And what we've done is put that right into the edit. So while you're working on it, they can get that history, and that can inform them and help them with things like test data as well. What are the abend conditions that happened in the past? And then code extract is what I mentioned before, breaking things apart. So we can go in, identify where like business logic is and say, oh, here's a concentration of it. This would make a good section for me to break off. Right click, we go in, do all the calling logic, make a separate compilable subprogram with that. And they can go in, test it, put it into production. Everything will work the same, but you've split off. So now the logic that you work with a lot is in a separate program. And that makes it a lot easier to work with. So we automate all that. If you don't have these things, it is like navigating a maze in the dark. And I feel sorry for them. I mean, we were all there at one point picking up a new mainframe application and we didn't have the tools. And how did you learn? Right? How did you learn? We were traumatized by that experience. There's no reason why we have to pass that on. This is not a hazing ritual. It's trying to get people to work with applications. So we had all these tools and we've been working with them, had great success with companies, but there was a piece that was missing and it's been bothering me for like 20, 25 years. People would say, oh, that's great and that's helpful, but could you explain what the code does? And I'd be like, how can I code up something that would explain like it's a banking application or validates, like I couldn't do that until last year when we found out, oh yeah, AI can do that. And so that's what we have right now in beta, and we'll be putting it out in October, is the ability to go in and do a right click on the code, and it will go in and it explains it. And it will tell me this section of code, what it does is it validates this field, or it goes in and writes out this output. It gives me a good English understanding of the code. It also has the ability where I can make it a comment. So I can have it in comment, I can have it in all caps because it's mainframe if I want, and I can then copy it and paste it where it is, or it will say wherever at the beginning, we'll just insert it there. So that way, again, leaving your code better than it was before. If it doesn't have comments while I'm in there, that could be part of your turnover process, is add new comments. And that, to me, is the real thing that we were missing, and we finally have it with AI. And it's a great use of AI to be able to go in and explain the code. And that is like flipping on the lights in that dark room. That's the final piece we had. So we have the ability to go in, start with an application I know nothing about, and execute it and have it instantly chart out how it works. And then once you find, I always say that's to find your suspects. Okay, I see a lot of processing here, or this uses this DB2 table. I want to work with that program. Once we find those, we can bring them up in Code Insights and see that charting and understand it. And then we can go in and start to make our changes all from the editor while they're working with the code. So I got it live here if you want to see it. And here's I've got the code here, and that could come right up from like your source code management. It's in the editor. I'm in Eclipse, also VS Code coming. I can work with it. I have my structure chart right there. And as I'm working with the code, I can see where it is. I can see where it does like the DB2 calls, IMS, the files, input and output. I understand it there. I can also see the logic flow for each paragraph. And I can go in and do the explain again. So I can just say explain code selection. And there it is. So it can quickly go in and tell me what it does. Like this, it validates data, processes style information. This program's our demo program on garments and clothing and how to calculate them. So it talks about that and how it goes and prices that. And then it goes through it. Not only you have the summary of a sentence or two at the beginning, then it goes down and gives you more detail later on with it's not a line by line, again, it's a summary, but says it starts out by doing this and then it does this. This is perfect for a comment because then I can go in and say, I want to make it a copy, and then I can go in and paste it right above where I've got it. Making things better. I mean, to me, I think of when I started, if I had this stuff, I mean, this is what we need to keep COBOL vital and to get past that fear of change. The fear of change, I hear it over and over, and that is our critical issue.
Is the product named DevX Workbench?
DevX Workbench is our Eclipse workbench where all of our products slot. This product is BMC AMI DevX Code Insights.
Okay.
And then it has some features like the Runtime Visualizer I mentioned, Code Extract, and Code Explain. So that's the Runtime Visualizer, again, where it goes through and charts out the interactions of multiple programs. And then it will tell you how many times it might have called something. We had a customer once where they ran this and they were shocked because it was pinging this one DB2 table like 1,000 times, and it's supposed to just hit it once and then fill up a table. And so it was working that way for years. It works fine, but it's a waste. So they never saw it until they saw this. And so why is it calling that so many times? It really tells you how it really works, which may be different than how you think it works.
How'd you train? What did you use to train the LLLN model to do that nice little trick about the code explain? Old COBOL programs?
Yeah, it would be really on anything you have. So there's been some training, but then once it gets to the site, then they're going to go through and train it on their own and learn from that.
Their code, because that's the code they're going to be working on. Yeah.
Right. Yeah. And that would be an on-prem solution.
So make sure I understand the answer. You're not doing you're not including any pre-generated, or you are so when you bring it in, is it completely empty and starts from scratch with what you add as the customer, or does it have a pre-existing data that adds with yours?
We've worked with things like the prompts to get the best response, but we're not supplying much more past that, right? There's nothing. You'll get more into AI, so.
Yeah, it's heavily driven through prompt engineering right now.
That was I appreciate that question, because my assumption was it contained something. Something generic.
Something's got to be there.
But it might be best, I guess, you look from engineering side, just leave it blank and give them the tools to
right.
their own stuff.
We do that, and it's more through the prompts, and then they learn. Because otherwise, what I have in my application isn't what you have.
Yep, makes sense.
What do you feel is the statistic for accuracy in your AI explanation?
Well, that's where we're coming back from our beta customers. It's actually pretty good. I mean, I've been impressed, even like with Assembler. I was shocked at how well it did. Yeah. Okay. Well, it really depends on what you give it. If you have code where the paragraph names are not descriptive, it can't guess.
Yeah.
So you have to put it under, if it's pretty well documented with some names, it can do great.
Can it go back to the working storage, for example, and pull down names so it has an idea of data types and that?
That's good.
That's going to be kind of the next step. We're also looking at if you have I give it a snippet of code like this and it performs, then we'll go into the perform paragraphs and give them an option like, do you want to go deeper? And that would be the other thing. So normally we do it on just
that blue highlighted code.
Right. But then we'll give them, and you can also do the whole program as well. And that might be something you want to save for,
Mark, what languages does it support? Is it just COBOL? Because you mentioned assembler briefly.
We're right now doing beta for COBOL. When we go GA, we'll have PL1 and assembler. And then we'll be looking at like Rex and JCL.
Go ahead.
And that was going to be my follow-up question about JCL and proclibs and that, because obviously the end-to-end picture to the real file name, to the DD name, to the actual COBOL program.
Green.
Yeah, to the screen. That.
Yeah, it's still early days on this,
Yeah.
but the beauty of the AI is it doesn't really care. It's just text.
I had Chat GPT try to come up with an assembler program just to add a couple of binary fields. It was awful.
Yeah.
See, Jeff,
It's totally unusable.
Yeah.
so Jeff, I have totally the opposite experience. I was writing some code the other day and thought, I need a bit of code to do this. I went to ChatGPT, asked it a question and said, no, this is illegal. Because I asked it, can you write me a ransomware package in assembler? And it said no. But then I asked it,
Question to ask it.
Good question.
then I asked it another question, can you give me a code sample for the KMC instruction? 4 or 5 lines of code, copied it, pasted it in, done.
Wow. Yeah, you shouldn't have told
Depends
me
what you
that.
ask it.
Yeah.
Makes me
yeah.
Part
Yeah,
of the
it's how you
right.
makes
Yeah.
me know that Chat GPT came up with some assembler that
and Rex.
yeah, I don't want to.
My students use it for their Rex homework. I advise them not to. It's bad. But
Yeah.
it answers correctly, but it layers in so much stuff that I'm like, you didn't do this.
Yeah. And we're looking at this point of just understanding it, which is great for like your students. If there's looking at Rex, it's like we at least give them a good explanation that they can go in, and then they can go in and get into more details.
I like this product because you're taking the code and explaining what it's doing rather than the other way around,
Right. Right.
which I don't believe in.
Quick question from me, Mark. So if you, I think I'm hearing that there's insight being provided effectively at an execution time, but also at a static analysis
Both.
time, right?
Yes.
So what's, if you don't mind, can you explain the relationship between those two things? Because that's when it gets really exciting. You know, at runtime, something's happening, and I want to know what's causing it in the code.
Mm-hmm. Mm-hmm.
Now you got to
That's
do
my
some
big
work
part,
there.
of
You got to
course.
do some.
And I know I'm asking for the moon.
No, I'm with you.
You know,
He wants to just
So
know.
what we have now is it will go in and like in this case, it says, I've got this program. And so I have the information over there. It's Enterprise COBOL. And then it goes and does this and this. For this, it isn't a right click and you just bring it up because we don't know where it is in the source.
Right,
We're
yeah.
working on hooking that together. But if I had that program like over here, then I would have that analysis. And that's why I said this is to get my suspects. I might have 50 programs and then look at it and go, it has to do something with this DB2 table. What things go with that? Oh, this one does it more than the others. Let me look at that. Then you bring it up for the program and you look at it and you go, that's it.
Right.
So this is a great way to understand how it all works, get your suspect programs,
And
then go into them
yeah, that makes sense.
and just go through levels. And then once you bring it in, it might be, I'm interested in this field. We have the data flow. So it goes and shows, it changes names and it goes through there, but it hits those. And in the chart, we put in red where it is. And you say, oh, it's clustered in here or it's there, which is also what we use for the extract to decide what to go out.
Okay.
So we do so much without AI that we waited until AI actually does the things we can't do.
Unlike Derek's aspiration.
Well, if you don't shoot for the moon.
I mean, you really have it at this point because you have the runtime visualization, which I think is unique in the industry because it's real. There's no instrumentation, nothing. You just run it and it charts it, figure it out from there, get your programs, dig into them, and it works from your editor.
Yeah.
So that while I'm editing the code, I can go and analyze it, reanalyze it, and understand it.
Yeah.
And
What information do you store about the Abend history? It's got a free-form area.
that comes from our Abend product.
Oh, good.
So what we do is you right-click on that program. We go out there and say, what do you got on that? And it brings it up and says, here's the Abends.
But there's free-form information that is there.
What it does, I'd have to go back to that chart, but it will show like it has the program, the paragraph where it abended, when it abended, what the code is, and then we also have a link where you can click it and go right to a web viewer and see the full report.
Oh, good. Okay. But the developer themselves
No, but the
can't put anything in?
no, what it does is it's just a right click and we get, here's the history of it.
Okay.
and they can go in there. But then you can again tell how often does it abend, what types of abends, what paragraphs. If I look at it and sees that it abends a lot in the paragraph I'm working on,
What about how they fixed it?
that's
That's another story.
yes, that's where we would head as well. Because yeah, once you have that, how do you tie what a fix was back to what they did, and it changes. But since we also have code pipeline where we know that whole history, that would be a natural place to tie those together.
The big deal.
But I think the Abend history is something we've overlooked.
Yeah, yeah.